Today we consider scientific notation. We're going to learn how to put numbers into and take numbers out of the scientific notation. So first of all, what is it? A number is written in scientific notation if it's in the form of c times 10 to the n. So you always see a number out front and then times 10 to the nth power. And that n and c can be whatever. Now there are some limitations to the c number here, the number out in front. That number has to be one number. So it can be from 1 and then less than 10. So it could be 1 point something, 1.2. It cannot be 0.3. You would have to move it over and make it 3 point something. And it cannot be 10 because that's two numbers. So it could be 9.8. That's fine. But it has to be one number, a decimal point, and then it can have some numbers after the decimal point, but only one number in front of the decimal point. So for instance, we could have a number like 4.26 times 10 to the third. That's a number that's in scientific notation. And we're going to talk in a little bit about how to get numbers out of scientific notation and how to put them into scientific notation. But first, why write scientific notation? Why write something like this? Now this one's not too bad because we would move the decimal 3 spots to the right, so it'd be 4,260. That one's not too bad. But if we get really big numbers with 10, 20, 30, 100 zeros, they get pretty big to write in a research paper that you do. So it's a way to shorten numbers up to make them more readable and gives you a better idea of what they really are. So let's first look at now the first example is to take numbers out of scientific notation and put them into regular numbers. So this times 10 to the 4 is really times 10,000. This number times 10,000. But there's a shortcut. The 4 here represents how many times we have to move the decimal to the right. When it's positive, we move to the right. In this case, in the second example, when it's negative, we move to the left. So what I want to do is take my number and move the decimal 4 places to the right. 1, 2, 3, 4. So I need to put in zeros here because there's nothing there. And my decimal point is now going to be right at the end there. So now my number is 23900. So 23,900. With the second example, it's 1.0 times 10 to the negative 2. So I'm going to move that to the left 2 points, 2 spots. So it's 0.010. I don't need to write that last 0. So remember, if it's positive, I go to the right. If it's negative, I go to the left. Now 3.7 times 10 to the 7th. So this time, 7 spots to the right. So think this is a pretty big number, 10 to the 7th. So my number down here better get bigger. 10 to the negative second, it's like 1 over 10 squared. Remember your negative exponents? That's a pretty small number. It's going to make the 1 smaller. Right, so think, what is this second number doing? In the first and third case, it's making it bigger. So 7 spots. So 1, 2, 3, 4, 5, 6, 7. So I make little dips like that, and then in every one of them I got to put a 0. And I can check it in a second. 1, 2, 3, 4, 5, 6, 7. Yep, my decimal point will be right there. So 37 million is 3.7 times 10 to the 7th. We need to write the number now in scientific notation. So remember, we have to move the decimal point so it's between just one number. It's got to be between the 3 and the 4. So we've moved it 1, 2, 3, 4 spots. So our scientific notation is 3.4 times 10 to the 4th. Now, positive or negative? Good question. This is a big number, way bigger than 1, so it's going to be a positive number. When it's a big number and we want to change it to scientific notation, it's positive. In the second case here, it's a pretty small number. It's a decimal. 1, 2, 3, 4, 5. So I move the decimal after the first number. So 4.56 times 10, and it's a small decimal number, so it's going to be negative. 1, 2, 3, 4, 5. So 4.56 times 10 to the negative 5th. So always move the decimal until you have only one number in front of the decimal, one non-zero number. So here is 4.23, and it's a big number, bigger than 1, so times 10 to the positive second. In example 3, we want to simplify these expressions. So I have 2.5 times 10 to the 4th times 5.8 times 10 squared. What I'm going to do is rearrange it. I'm going to put the numbers by each other. 2.5 times 5.8 times 10 to the 4th times 10 squared. So I can simplify the second part to 10 to the 6. Remember, they each have their own base, the same base, 10. So I can add the exponents. And then 2.5 times 5.8 is 14.5. So 14.5 times 10 to the 6th. Problem is, that number is not in scientific notation. So I need to move that point over one spot. Right here from after the 4 to before the 4. But that means I have to adjust the 6 now to be a 7. Remember, that's a bigger number. 14 is a bigger number than 1. So I need to make it smaller. So to be times 10 to the 7th now, because I moved it over one more spot. So 1.45 times 10 to the 7th. So first, by multiplying these two numbers, the two sets that I rearranged, I could easily combine these in pieces of information. And so these two, I just had to make sure my number was in scientific notation, only one number before the decimal point. In the next example, we're going to divide. 1.82 times 10 to the negative 1st over 1.4 times 10 to the negative 3rd. So I'm going to do it similar to what we've done before, kind of divide it up into two separate problems here. Do the 1.82 divided by 1.4, and I get 1.3. And then here, it's division of powers, same base, so negative 1 minus a negative 3, or negative 1 plus 3, which is 2. So again, negative 1 minus a negative or plus 3. So that equals 1.3 times 10 squared, and there's only one number in front of the decimal, so I'm good. And the last example here on this slide, we have the 3. Remember, that gets given to each item here. So it's going to be 1.5 to the 3rd times 10 to the negative 4th raised to the 3rd power. So 1.5 to the 3rd is 3.375 times 10, and I'm going to multiply. It's a power to a power, so times 10 to the negative 12th. Now, it doesn't matter how many decimal places you have after. You could have a lot of them. It doesn't make sense to put too many, because the purpose of scientific notation is to make it an easier number to work with. Final example for today. In 1997, cell phone bills totaled about 2.75 times 10 to the 10th dollars. There are 55 million subscribers. What's the average monthly cost per subscriber? So we're going to do dollars over subscribers. Now 55 million. Let's write that number out. And let's convert that number to scientific notation first so we can divide like we did in the previous slide. 1, 2, 3, 4, 5, 6, and then 7. So 5.5 times 10 to the positive 7 because it's a big number, bigger than 1. So it's going to be a positive number. So I want to divide this number by 5.5 times 10 to the 7th. So again, two problems. 2.75 divided by 5.5 gives you 0.5 times 10. Now division, 10 minus 7 is times 10 to the third. Okay, but we got a small number there, less than 1. We don't have a number in front of the decimal, and in scientific notation we need to, so we need to move the decimal over 1 to the right. And this number's smaller, so we gotta lessen the exponent. So 5 times 10 squared. If we want to see that, if we can write that out, 0.5 to the third would be moving it 3 spots, 1, 2, 3, so it would be 500. So if you're not comfortable going for the 3 to the 2, you can write it out, but then say, okay, I want to write it in scientific notation, numbers bigger than 1, so I need to move the decimal 2 spots to the left. So 5 times 10 squared. So that gives you two different ways to go about doing that one.